Well, hey there, kiddos. Today we are going to talk about adding and subtracting polynomials, which is really not a new concept. We have done this before. Before, when we did this, we called it adding like terms or combining like terms. It is the same thing, but there is some new vocabulary to go with it, and it's good to review because it is an important skill. So the first little vocabulary word we have to deal with is a monomial. And here's the definition of a monomial. It is a number, a variable, or a product of the two. So for example, 2 could be considered a monomial. X is also considered a monomial, or I could put them together. 2x is also a monomial. Just monomials cannot have addition or subtraction signs. It has to be a product. A binomial is nothing more than a sum of 2 monomials. So that's when I take 2 monomials and I put them together. For example, 2x plus 8. That's a binomial. And so a trinomial, I'm sure you can guess, is a sum of 3 monomials. And they usually look something like this: x squared plus 2x minus 4. I know that it says sum, but remember minus is the same thing as plus a negative, and so it's still a sum. We just took out the plus sign. After 3 monomials, we quit giving them specific names and we just call it a polynomial. A polynomial is just the sum of many. Actually, we're going to do this. It's the sum of 2 or more monomials. And so a binomial and a trinomial are also polynomials. They just have special names. Anything after that no longer has a special name. It's just a polynomial. The one you are going to see the most often is a trinomial. We'll deal with that more than anything else. But so that's where we are. So those are our definitions. Monomial is 1, binomial is 2, trinomial is 3, and then a polynomial is 2 or more of them. So let's do some practice. So we have these 2 problems involving algebra tiles. We're going to add them together, and we're going to practice this using algebra tiles. I'm going to be able to move mine around. You won't. You're going to have to draw, but I'm going to be able to grab mine and drag them around. But so you're just going to draw what we're going to do. Now we're going to add these up, and if you'll remember before we talked about algebra tiles, the gray or the shaded in ones are going to be negatives, and then the unshaded ones or the white ones will be positives. And so we're going to add these together. You can only add things that are the same size together. So I have 2 negative x squareds and 1 positive x, and I want to add them together. Well, if I take 2 negatives and 1 positive, one of the negatives is going to cancel out the positive because it makes a 0 pair. And so since they are going to cancel each other out, I'm going to grab my pen and show you. This one will cancel out this one, and since they cancel each other out, all that I have left is this 1 negative x squared. So now we have to deal with the x's. I have 1, 2, 3, 4 x's, and then I have 1, 2 negative x's and another positive x. Well, these 2 negative x's are going to cancel out 2 of these positive x's because, again, they're going to make 0 pairs. So this one will cancel out this one. This one will cancel out this one. And so I have 1, 2, 3 positive x's left. And so I'm going to have to put in my 3 positive x's. So I have 1, 2, 3. And then this has no anything else left. I'm done with this one over here. But I have 2 negative 1s over here. And so I'm going to have to put in my 2 negative 1s. So when I put them in here, here is what I have left. And I'm going to write this out algebraically so I can see algebraically what it looks like. I have 1x squared plus 3x's. It's plus because they're positive, minus 2 because I had 2 1s. And so this is a trinomial, x squared plus 3x minus 2. And we say it's a trinomial that to the 2nd degree because the highest exponent is a 2 in that problem. So this is a 2nd degree polynomial. So if you're ever asked to give them to the degree, polynomial. Wow, I had trouble spelling that. You always just, when you're asking for the degree, just always go look for the highest exponent, and that will give you your degree. So now let's do the next one. So they want us to write a polynomial to represent the measure of this angle ABD, the whole big one, which means I have to add the two smaller ones together. Again, it's just combining like terms. So I have 8a squared minus 2a plus 5 plus 7a plus 4. So I'm going to take like terms with like terms. I have an 8a squared here, but I have no squareds over here, which means I just get to bring it down because it gets to come along for the ride. Then I have a minus 2a and a plus 7a right here. Well, when I do negative 2 plus 7, that makes positive 5a. And then I have positive 5 plus positive 4. When I do 5 plus 4, that gives me 9. So there is my polynomial that represents the measure of this entire angle. Again, it's a trinomial because there's 1, 2, 3 terms, and it is a second degree because my highest exponent is a 2. So now let's talk about addition versus subtraction. Subtraction is going to be what messes with you the most because you're going to forget that you're subtracting and we just start combining like terms, but we'll review it. So addition is simple. Like terms with like terms. So I have a 5a to the third plus a 7a to the third. And when I do 5 plus 7, that becomes 12a to the third power. Then I have this 3a squared. Well, and then I also have a 12a squared in the same set of parentheses. Well, I have to put them together because they are like. So 3 plus 12 becomes 15. So I have plus 15a squared. Then I have minus 6a plus negative 10a. Well, negative 6 plus negative 10 becomes negative 16a. And again, I have a trinomial because it has 1, 2, 3 terms, but this is to the third degree because it has the highest exponent is a 3. So this is a third degree polynomial. See if I can spell better this time. There we go. Now when you do subtraction, you're treating it the same way. You're still going to be combining like terms, but remember there is a minus sign in the middle here. So there's two ways to do this problem. The first way, you can just know that there's a minus sign here, and so you know that you are subtracting. Or you can distribute this negative to everything inside these parentheses and then go ahead and just combine like terms. I'm going to do it the first way. I'm just going to look and find my like terms, and then I'm going to remember there's a minus sign in the middle. So I have 6x squared and 2x squared, and there's a minus sign in the middle. So 6 minus 2 becomes 4x squared. Then I have 8xy minus 3xy. When I do 8 minus 3, that gives me 5xy. And here's where you have to be careful. Now I have negative 3y squared minus negative 2y squared. So what I have is negative 3 minus negative 2. And remember that minus a negative really makes that plus. So you have negative 3 plus 2, which becomes negative 1y squared. And you don't have to put the 1 unless you just, absolutely want to. So this again is a trinomial, and it's still a second degree polynomial because my highest exponent in any place is a second power, so it's a second degree. So subtraction, you can do it the way I just showed you, or you can distribute this negative through to everything and then just combine like terms. Whatever you like the best. I like to just keep it all and remember that I am doing minus instead of plus. It sort of helps me to keep things straight. So now let's fill in these missing statements in this table. We're going to do what it's asking us to do. So right here it says we need the sum. So I have my first polynomial and my second polynomial. They want us to add them. So it's just combining like terms. X squared plus 3x squared becomes 4x squared. Then there's no x term in this first one, but there is an x term in the second. So I have to put this minus 10x in as my next part of my polynomial. Then I have minus 6 plus 2. Well, negative 6 plus 2 becomes negative 4, and so there is the sum. Now the next part of this table becomes interesting because I have my first polynomial is missing. I have the second polynomial and the sum. In order to find the first polynomial, I have to go backwards, so I have to subtract. So I take my sum, which was 3x squared plus 2x plus 1, and I have to subtract the second polynomial. I'm going to write this just like it is. So I have x plus x squared plus 6. and I'm going to subtract. So like terms with like terms, I have 3x squared minus 1x squared, and 3 minus 1 becomes 2x squared. Then I'm going to do my x's, so I have 2x minus 1x, and 2 minus 1 gives me 1x. And then I'm going to do my numbers. I have 1 minus 6, and if I do 1 minus 6, that becomes negative 5. So there is your first polynomial, polynomial number 1. So pause for just a second. Try this last row on this table. See if you can find polynomial number 2 following basically what I just did in my example right here. So here's what I came up with after I subtracted these two polynomials. I got my second polynomial was negative 6x plus 14. My 7x to the thirds cancel each other out because I am doing subtraction. So I can just cross them out. They don't count. This negative 6x right here, I apologize, it is not a negative 6x. This negative sign in front of these parentheses cancels out this negative sign in front of the x and makes it 6x. You still have to consider that you are doing 0 because there's no x over here, so you're doing 0 minus negative 6, which is the same thing as plus 6, so it becomes positive. And then when I did my numbers, I had 11 minus negative 3, which actually was 11 plus 3, so it made 14. So your missing polynomial should be 6x plus 14. And I'm going to show you one more time. If you do it the other way that I told you, so you have your 7x to the third plus 11. And then I'm going to distribute this negative to everything that was already here. It becomes minus 7x to the third. This negative and that negative make a plus 6x, and this negative and this negative make a plus 3. And so then when you combine like terms, these still cancel because of the minus sign, but then you have a positive 6x, and 11 plus 3 makes 14. So that is the other way to do it so that you can see why that was positive. But that is adding and subtracting. So we're going to do one more problem. It says to draw a picture and then solve. You should actually draw the picture. It is honestly helpful to draw the picture, label all the parts, and then do what it asks. So it tells you that the length of a rectangle is represented by 2x plus 3 feet, and its width is represented by 3x plus 7 feet. So I know I've got a rectangle, so I'm going to draw a rectangle, and I'm going to label it. The length is 2x plus 3, and because it's a rectangle, there are two lengths. You have to label them both. If you just label one of them, it's inevitable that you're just going to add two sides and then you'll get confused. The width is 3x plus 7, so I'm going to label both of those. Excuse me. Then it says that the perimeter of the rectangle is 35 feet. They want you to find the value of x. We got to find out what x equals. Well, the first thing we have to do, this is a perimeter problem, is add up all our sides. Well, we've done this 100 times before, so I'm going to combine like terms. 2x plus 2x is 4x, plus 3x makes 7x, plus another 3x makes 10x. If you add it a different way, it doesn't matter, just as long as you get 10x. And then you add your numbers. 7 plus 3 makes 10, this 7 plus 3 makes 10, and 10 plus 10 is 20. And altogether, that perimeter is 35. So now I'm going to solve this equation I've just written for x by subtracting 20 from both sides. So I have 10x is equal to 15, and then I'm going to divide by 10 on both sides, and so I get that x equals 1.5 feet. That's what x is. Alright, I don't guess we actually have to put the feet, but x equals 1.5, so when I do 15 divided by 10, that's what I get. That's the value of x that will give you a perimeter of 35. So it's just a review. We're just combining like terms. Make sure you do like terms with like terms and keep up with your signs, especially when you are subtracting or when there are negatives involved. So we'll practice this tomorrow in class. I will see you then.